In this video, we're going to be looking at a different way to do polynomial division. Now, it's called synthetic division. It can only be used when we have x minus something or x plus something. What we're going to do is just list out coefficients. We're going to only worry about our coefficients. We're going to put in zeros for any missing terms. So if you look at this example, we have x cubed, so the coefficient there was 1. X squared is missing, so there's a 0. The coefficient of x is -2, and our constant is 12. Now, we're going to put on the outside whatever is the 0 for what we're dividing by. So x plus 3, we're going to put a -3 right here. All right, so what we're going to do is bring down the first term, and now we're going to multiply. 1 times -3 is going to give me a -3, and our next step is that we're going to add. So 0 plus -3 is -3. -3 times -3, I'm multiplying again. -3 times -3 is going to give me a 9. -2 plus 9 gives me a 7. Well, we're going to multiply to find what goes there. So 7 times -3 gives me a -21. And then we're going to add. 12 plus -21 is going to give me a -9. What I want you to do is compare that to when we had the same problem in the lesson on long division. In the lesson on long division, we ended up with x squared minus 3x plus 7, and -9 was our remainder. And if we look here, those are basically listing out our coefficients. 1 would be our 1x squared, the -3 would be the next term, and the 7 would be the constant. -9 is the remainder, exactly like what we got from doing long division. Now this one does go a lot faster. So let's try this next one. If we're dividing by x minus 3, then we're going to put a 3 on the outside. Now I'm going to list all of my coefficients. 2x cubed, 9x squared, 14x, and a 5. Now a remainder is going to go underneath our last term there. Our first step is to bring down the first coefficient. Now we multiply. 2 times 3, 6. We add. 9 plus 6 is 15. 15 times 3 is 45. We add. 14 plus 45 is 59. Now we're going to multiply. I get 177, and then we're going to add. That gives me 5 plus 177 is going to be 182. So for this problem, we would get, since there's 3 terms, that would be x squared to start off with, 2x squared plus 15x plus 59, and a remainder of 182 over x minus 3. Now, if you ever have trouble remembering what this is going to start off with, if we had x cubed here and divide by an x, our quotient is going to have to start with x squared. Now, there's a neat point here. What if we plugged in 3 into our polynomial? So I'm going to speed things up and use my calculator here. So 2 times 3 cubed plus 9 times 3 squared plus 14 times 3 plus 5. We get 182. So another use for synthetic division is what is called synthetic substitution. We get the same answer. This is also the remainder theorem. The remainder theorem says that our remainder is the same as what we would get if we had plugged that number directly in for x. So pretty nifty. Now, let's take the next one. I'm stating here that x minus 2 is a factor of this polynomial. Now, if you remember what it means to be a factor, A factor is something that divides into something evenly. So let's see what happens when we divide by something that's a factor. Now you should remember, like for example, 2 is a factor of 12. If I divide 12 by 2, that means it divides evenly. Do I have a remainder? No. So let's see if that happens in synthetic division as well. Bring down my first term. 1 times 2 is 2. We're going to add down. So negative 5 plus 2 is negative 3. Multiply. Negative 3 times 2 and get negative 6. Add down. Negative 18. Multiply. Get negative 36. And I get a remainder of 0. That proves that x minus 2 is a factor of this polynomial because we got a remainder of 0. What's nice is it's also a way that we could actually factor that polynomial. It's sort of like when we factored the number 12 and we realize that's 2 times 6. Well, then we can break it down and factor what's left. We can do the same thing with polynomials. I know x minus 2 is a factor, and when I divide that by x minus 2, this is what I get left. X squared minus 3x minus 18. Now, I can try to factor that if I want. Let's see if it does. Multiplies to be negative 18 and adds to be negative 3. Ooh, it does. Now, if I was unsure if I factored it correctly, I could always do synthetic division with the 6, and I should get a remainder of 0, or with the negative 3, and I'd still get a remainder of 0. This is what is called the factor theorem. If you divide by something that's a factor, your remainder will be 0.